Hey guys, and welcome back to a new video. In this video, I will show you how you can implement file uploads and file downloads in your Spring Boot backend with Java. If you know my channel for a while already, you may ask, hey, why Java? Why not Kotlin? Because most of my content is in Kotlin. But since Java is still the main language used for Spring Boot across the industry, I also want to make a bit of Java here and there. But if you come from a Java background here and you have no clue of Kotlin, I can still highly recommend to try it out. I have a Spring Boot crash course in Kotlin, for example. So in the end, after watching the video, what you will be able to do is you will have an endpoint upload for images, but that also works with any other files. And then you can attach certain files here, new file from local machine. I select an image here, click open. And then if we send this request, it says, okay, if we take a look at the body, we get back the file size, the original name, the ID. And if we then take the ID and copy that to our other endpoint here, paste that in our URL, and then click send, then going to body will give us here this very large, beautiful image. And I can also already say right away, this won't be the typical Spring Boot file upload download video here that you will find on YouTube, because very often people just show you, hey, that's a multi-part request, that's how you upload a file. Okay, here you have some kind of input stream, do whatever you want with that. Here's how you download that. I really want to give you the production approach here. I want to share best practices when it comes to file storage. I will share some security best practices. I will show you how you can really take this logic, this file storage logic, and integrate this into a proper Spring Boot architecture. So I'm here in a blank Spring Boot Java project. You can see I just have my application. And in our build.gradle KTS file, or whatever version dependency manager you use, I really just have the Spring Boot starter web dependency and MongoDB, because MongoDB will be used here for storing metadata for images that we've uploaded. That's already the first best practice that I can recommend to stick to here, because I very often see people do this, that they take the actual raw image, so the actual raw bytes, and they maybe base64 encode that in some way, just to be able to somehow push that into a database document or database entry. And that's something that is typically not a smart thing to do, because database cells, or in this case MongoDB documents, they all do have a maximum limit there. Saving such large data can make your queries slower. So much better is if you actually take the files and store them on some sort of real file system, and then just save the metadata that really links to those files. So with the relative path, with maybe the file size, the MIME type, save that in a database table. So you can iterate over this database table very quickly with your queries. And then if you want to really download and provide such an image, you get the file path linking to that image from your DB table. And at this point, we also need to talk about the different options that you have when storing images or files in general. And that is on the one hand, local storage. So you host your Spring Boot backend on some kind of maybe Ubuntu server. Then you can, of course, store these files on your local Ubuntu file system. That is what we will do here. But I also want to highlight that very often in production, you definitely want to consider some kind of remote storage. So something like Amazon S3. So we just have some kind of third-party service that stores your images for you. This has the advantage that you pretty much have unlimited scalability, because you don't need to worry about your file system anymore. It has built-in redundancy. It's much easier to add backups if you actually rely on something like S3. And also if you maybe provide your files, your images across the world, then it also makes it easier to have this geographic distribution, so that, for example, users in Europe would also prefer getting images from European servers and so on. On the other hand, the downsides of using such a cloud provider is of course latency, because first of all, the user uploads the image to your backend, and your backend again uploads it to such a cloud provider. It of course comes with higher costs, and you of course have an external dependency that your code in the end depends on, which is something that I would also generally want to minimize, but it's always of course a trade-off. That's just as a little disclaimer here before we go on, because I already see the comments, oh Philip, it's much better to store these images in S3. Yes, if you watch this video here, then you will also know how to take these images and do something else with these. In the end, you will have these images available on your server, and whether you then send these over to S3 or store these on your local file system, that's completely up to you. We will do the latter in this course. As a first step, I want to go in our root package and create something like a repository package in which we have our MongoDB repository storing the image metadata. So here in repository, we can create a new Java record, which we call image metadata. So that will represent our MongoDB document, make this a record. So if you come from Kotlin, that is the equivalent to a Kotlin data class. And well, now we need to think about what kinds of data we want to store in our MongoDB document. First of all, we need to tell this that this is a document, and we give this collection in MongoDB a name, like image metadata, for example. And then we say, well, I want to store a string here for the original name, so the original file name. However, the original file name, so how the file was called on the client device, is typically not what you want to use for the server side, because that can, of course, clash. You can have name conflicts, so it's much better to also have something like a stored name. We also want to keep a reference to the MIME type, so what kind of file we're actually working with. We want to maybe have something like an owner ID. That's just something I will hardcode here in this video. But if you, for example, have a social network app, social network website where users can upload images, then it, of course, makes sense to also store the ID of the user the image actually belongs to. We may want to have a long for the actual file size. Want to have an instant for when this file was created. And lastly, want to have a primary key here in MongoDB that is an object ID, which we call ID, just like that. And then the class body can stay empty. Other than that, in our repository package, we now need an interface that really implements this repository. But since Spring Boot is so great, we don't need to write any query that we need here on our own. So we can really just make this an image metadata repository, an interface. And we really just need to say, hey, this, that is Kotlin way of doing it. This extends a Mongo repository, which stores image metadata objects and has object ID values as the primary keys. And the body of this can really stay as it is. You would need to extend this if you would have more complex queries you would like to send to this repository or to your image metadata collection. But since we don't have that, we really just want to query single images by ID. That's something that is already contained here by default. Next up, what we want to work on are two services. So just classes that have the responsibility to, on the one hand, really store a file on the file system. That will be our local image storage service. And we will have another service, which we just call image service or so, which has the responsibility to really wire everything together to receive a multipart file, then interpret that, save that on the file system using our other service, save the metadata in our MongoDB collection, and so on. So here in our root package, let's create a new package called service or services. Let's say singular service. And in there, we first of all want to declare some properties that we can then use in both our services that just both of these need, which we can call image storage properties. And this will be a record here. We want to annotate this with configuration properties. So this is really just a class that holds Spring Boot specific properties here. So constants. We can give this a prefix where we say, okay, app image storage or so. And then we also annotate this with component. So Spring Boot can easily inject this all over the place. In here, we will then want to store the base path. So the base path of where we want to store those images that we upload to the backend. And we want to have a set of strings, which are the allowed MIME types, because that's definitely one security best practice here, that if you store, for example, images on your backend, then you want to limit the MIME types that people can upload. So otherwise they could upload pretty much anything. And since this is pretty static here, we can initialize this in our constructor. So a public image storage properties in which we invoke this with a base path. The base path in this case is just images. So here in our local file hierarchy, I can say already, if you deploy this somewhere, then avoid storing these images in your actual Spring Boot working directory or your Spring Boot in the same directory where the Spring Boot backend is in, but rather place this somewhere on a static path in your file system, maybe in the /var path of your Linux backend, something like that. This is really just for testing purposes here, that we have a file path where we certainly have the permission here to also store files in. For the set, we can say set off and just specify our allowed image MIME types. So all these are image, but we, for example, want to allow JPEGs. We want to allow PNGs. We want to allow WebP and maybe GIFs or so. So image/GIF. And that's already our image storage properties, which you can now inject in our services. And then both these services can reference the same constants. So let's go to service and create a new Java class called local image storage service. We annotate this with service here in Spring Boot. And this class really just has the responsibility to store files here in our file system. It doesn't yet wire this together with our image metadata and so on. That's the responsibility of another service then. So first of all, I want to inject our image storage properties here. So image storage properties. I want to have a private final root path. So the root file path, which is a path. And then we can say Alt-Enter here to add constructor parameters. For both of these. When invoking the constructor here, we don't need to pass in the root path. We actually don't need this because the root path is initialized by using our properties because the base path is stored in there. So we can say paths.get, and we say we get our properties base path. That is the path that we want to use for our root path object that we then use in our service here. So let's actually start off with a function that saves a file, that returns the string, so the actual file path afterwards, which we can call store file. And this takes in an input stream, which we pass in from the outside, and the original file name, so string original name. It can throw IO exceptions in case something goes wrong. And then first of all, we need to think of an actual folder hierarchy that we want to stick to here that also later on makes it easy to find certain files. And well, an easy folder strategy here would just be by date. So we would say we have a local date now or today, which is equal to local date.now. And then with that information, we can declare a path, which we call date directory, which is equal to root path. So it should, of course, be relative to our root path. And we then call resolve with today.getYear. So that would be our first directory plus file.separator. So the file separator, whatever OS we are on, plus string.format. We want to format the month number now and the day number, %0 to D. We pass in today.getMonth, get month value here. This %0 to D in the end achieves that if we have some kind of month, 12 would result at 12 for December. But if the month is, for example, May, then this would be padded properly. So we end up with a directory that has a 0 as the leading number. Here afterwards, we want to have a file separator again. And lastly, you want to have the same also for the day. Get month should be replaced with get day of month. And that is now the directory path that we want to store in. So this will result in something like, so our root path where we say, okay, then we have 2025 / maybe June and June 15th, something like that. That will be the created file hierarchy here by using this logic. Then we can say files.create directories, where we simply pass in our date directory. So in case this hierarchy doesn't exist, we will simply create it with this command. And then lastly, we can create a path here for our actual file path. So where we want to store this file, which is equal to our date directory that resolves. So we simply append our original name. But we actually don't want to rely on the original name for the file path, as I mentioned at first. So we don't want to just take the user's file path here. On the one hand, to just avoid naming conflicts. If two people have the same file names, then these could be duplicated here. But also because this is quite risky in regards to security if the user could pass in any file name. Because who tells us that they don't pass something like this here and then try to read a password to text file? If we pass in this here to the original name, and that's something the client would provide, then unless we verify this in some other way, this could actually pretty much browse our directories. And if our Spring Boot app has the permissions to read from there, we could be unlucky and they could just query our file system. That's not what we want. So we want to generate unique file names here, for which I first of all create a little utility function here to extract the file extension. So private string get file extension for a specific file name. And for the file extension, that's pretty much what comes after the last dot. So you can already see some sample code here. But I want to implement this a little bit safer. So the last dot would be file name, last index of, yes, say that is a dot. And then we return whether this last dot is equal to -1. So it will return -1. If there is no dot, because there are also files without an extension, if it is -1, we say that is an empty string. If it's not -1, so we have a valid index, then we say file substring last dot +1. So what comes after the dot. Then here, before the file path, we can say string extension is equal to get file extension from our original name. So we, of course, still want to use the same file extension that was there for the file that the user has uploaded. And from that, we can then derive the stored name, which is equal to just something like a UUID. That's always something easy to generate something unique of. UUID just as a file name. And then we say, okay, plus whether the extension is empty. If it is empty, then just nothing. But if it is not empty, then we say a dot plus our extension. So for example, .png. And then the stored name is what we can pass in here for the final file path. So now we just need to take this path in a try block and actually write real bytes into it. So we can say output stream, want to write bytes out to a file that's equal to files.new output stream as the AI suggests here. Pass in our file path, we want to store this, and we say standard open option create new. So we're going to create a new file in case it doesn't exist. And here we can then say streamutils.copy. So we want to copy over the contents from the input stream we've passed to our output stream, just like that. And since this output stream here links to the file path, as we've passed this in here, this will really write or copy the contents from the input stream, which later on comes from a multipart request, to our output stream, so to the real file. And then lastly, we can return our root path that relativize, pass in our file path, and convert this to a string. So relativize is in the end the opposite of resolve. If we have some kind of path A, B, C, D, and our file path would be A, B, C, D, E, and we pass this in here, then the resulting path would just be the relative path. So the common parts would be cut off and the output would just be /e. So this is how we store files. The other function that we need here is, of course, to retrieve files and then later on respond with these from our API endpoint. So we can say with a public resource, or a resource here from Spring Framework Core IO, is really just what we should use here in order to provide a resource in some way, so some kind of file, for example, from an endpoint. We say get file resource, something like this. We pass in our stored name or stored path. This also throws IO exceptions. Then we can again define our different paths. So file path is equal to root path dot resolve with our storage path. We normalize this. So normalizing means it cuts off all the noise, so all the file hierarchy characters that in the end don't add any value. So for example, if we have a file name like this, then the hello.txt, then this dot slash, it doesn't add any value, and you can just remove this and relativize it, normalize it, sorry. And we then want to convert this to an absolute path, and the same we want to do for the normalized root. So normalized root path, which is simply root path.normalize, and also have this as an absolute path. The reason I'm doing this is that I now want to have an if check. If the file path does not start with our normalized root path, what this means is someone is actually trying to browse our file hierarchy. So the same scenario that I've shown you before here for storing the file, if we would solely rely on the original name to dictate also where and how this file is called on the server side, this would be a security issue. But just because clients cannot directly provide this, the risk is still there that the file path here could be something like this here. And that is where we convert this file path to an absolute path. So these double dots here are actually removed and the real absolute file path is returned. Because if this absolute file path does not start with our root file path, then that means someone tried to mess with our file path and navigate somewhere where they shouldn't navigate. And this could, of course, also be the case if someone, I don't know, compromises your database with the file metadata and then changes the file metadata to some kind of relative strings here. That's also something we want to avoid and to really just add a double check here after all. In this case, we want to throw a new security exception. So we say access denied because we only want this code to return or to be able to return files inside of our images base directory. Also in case this file does not exist, so if files.exists for our file path, then we want to throw a new file not found exception It's that easy. And lastly, we can return a new URL resource because we provide this file from a URL. And we can say filepath.toURI, semicolon, and that's it. That's how you retrieve files as resources in Spring Boot. That should be it for our service here, for our local image storage service. Next up, we need an image service that really takes this service and makes use of the functions we've implemented here, and also implements them together with our image metadata, so that the metadata is really stored in our MongoDB instance. So in service, let's have another image service that wires these things together. We annotate this with service, and in here we have some private final fields that we want to inject. So on the one hand, our image storage properties again. We want to have a private final image metadata repository now. And we need a reference to our other service. So our, what is it called? Local image storage service. Let's call it storage service. And then we can hit Alt-Enter here to add constructor parameters, generate a constructor from all these 3 fields, and then everything will be wired together by Spring Boot. Then we want to have a function, a public image metadata function, so that returns an image metadata object that in the end is called upload image. And here I want to pass in this multi-part file reference already, because that is really how file uploads works with REST APIs. So while normal or typical requests just include some kind of maybe JSON body where the request consists of one single part that is uploaded to the server, there are certain requests where the request consists of multiple parts. So maybe a JSON body, maybe one or multiple files, and that works with these multi-part requests. And Spring Boot simply receives these as a multi-part file object, which we can then get all the information about the file from. So upload image, we need to know the owner ID together with that in case you want to have behavior like that. And then first of all, we want to have some double checking here that we validate this uploaded image, that it actually fits in our requirements, that it has the right MIME type and these kinds of things. So private void validate image. We pass in this multi-part file. And first of all, check if this file is empty. So if there are no bytes in the file, then we want to throw a new illegal argument exception where we say file is empty. That should not be allowed to store empty files in our server. Other than that, we want to get the MIME type from the file, which is equal to file.getContentType. And if that MIME type is equal to null, so there is no MIME type, or or properties, allowed MIME types, does not contain this MIME type, so it's not in our contain MIME types map or set it is, then we also want to throw a new illegal argument exception, invalid MIME type. Just want to say, in a real backend, you would probably also want to have a double check that the real MIME type of the file is also what the client tells it is. Because you can technically change the MIME type and maybe make an EXE file tell you that it's maybe a PNG file. So this is technically possible, but checking that is a little bit more difficult. We want to use this validate image function in here, pass in our file, and if this function did not throw anything, we know that we are working with an invalid image. So we can then get the storage path here as a string. We say try, create an input stream. So an input stream where we can then in the end read the file from, and that's simply coming from our file get input stream. So this already comes from Spring Boot's multi-part file object. So we can then go inside of this try block and say storage path is equal to our storage service that we've implemented, and we want to store this file by passing in this input stream, and the original name is equal to file get original name. So that's also part of the multi-part request. We get some errors here because this could throw an IO exception. We need to add this here as an information. So throws IO exception, and then these errors are going away. And now that we've really stored this file here, the next step would be to have an image metadata object. So we also store the metadata of that file in our DB, so we can then query which files we actually have stored where, and if we want one, then we know the file path to look for. So image metadata is equal to new image metadata, where we now need to pass the original name, which is coming from the multi-part file. The stored name is our storage path. The MIME type is our file get content type. The owner ID is passed to this function. The size is equal to file.getSize. And the instant created at can just be instant.now. And lastly, we can say object id.get to generate a new random MongoDB object ID. So that is now our image metadata object that we want to store in our DB. And then we can simply say repository, save, and we save that metadata object. It's really that easy. So this is how we can upload images here and wire these things together. Same thing is now necessary for downloading these, or to rather take an existing image metadata object, retrieve the file that belongs to that, and get it as a resource. This is much easier, by the way, than uploading, or requires less code at least. So here we can say we have a function that returns an image metadata object from our DB, get image metadata by the certain image ID that is then provided as a URL parameter that maybe throws an IO exception. We can then construct the object ID out of our string ID, just like that. It's new object ID, just like the AI tells us. And then in here, we can then return repository, find by ID. So to find a certain image metadata object by the ID that we've passed here, specifically the object ID, and then or else throw. So either it finds something, but if it doesn't, then it throws something, specifically an exception. So new file not found exception, for example. File not found. And now with this image metadata object, we can also then retrieve this as a resource, so as something that Spring Boot can really respond with for a URL endpoint. So a public resource again from Spring Framework Core IO, get image resource, pass in this image ID. This also throws an IO exception. We can first of all retrieve the metadata object by saying get image metadata using our function that we've just created while passing in our image ID. And then we can return our storage service, so what we've implemented before, .get file resource, and we pass in the stored path, which comes from our metadata object, .stored name, just like that. And this resource that we then return is finally what we can also then respond with in our controller, which is really the last part of this backend. So we need a controller that accepts these REST requests to our two endpoints, and then on the one hand receives a file, saves it in our storage by calling this upload image function, and the other endpoint will of course call the get image resource function. So new package controller, in which we create a new Java class called image controller. Let's call it like that. This will be a REST controller, so a class that receives REST requests and processes these, and we will add a request mapping to have a relative URL for all endpoints in here called images. We do need our image service being passed in here, so private final image service, Alt-Enter to add the constructor parameter, and then we can create two functions, on the one hand to receive a multi-part request, and the other one will respond with image data. So starting with the upload part, this will be a public response entity with a question mark, so could return anything, upload image, and this will here get a request parameter, which is called file. So this is the key that the client also needs to know about. And it will be a multi-part file called file. And then in here, this file will then contain the actual file contents. So if the client uploads this as a multi-part request, then this will automatically be included here. This also needs to be a post request. So we say this is the post mapping, and it gets a relative URL /upload. So we can then call our localhost /images/upload, and then this function here will be triggered. I want to simply hardcode the owner ID here, of course, in a normal backend. You would retrieve this from, for example, a JWT claim or so, if you have this in our simple backend here. We don't have owners or the concept of that. So we can then say we have a try and catch block to handle these possible exceptions that can happen here. On the one hand, IO exceptions. On the other hand, illegal argument exceptions we've dealt with in our services. But first of all, trying that everything is the happy path here. So we want to try to have an image metadata object that we retrieve from our image service, that upload image. So we just call our function that we've implemented here, pass in our multi-part file and the owner ID. And if that did not throw, we can say we return a response entity .ok. And here you could technically return some kind of body if you want. You could create a record for that, or we just create a map.off. And here we could then have map.entry. On the one hand, for what do we care about? The image ID, of course, what we stored server sides that's needed to request that image later on. This will be metadata ID to hex string to just return the MongoDB ID as a string. And we could have two other entries, one for the actual original name, for example, which the client probably already has, but we can also return this, just original name. And lastly, the file size. So here size is equal to metadata.size, something like this. And then what does this complain about? Remove redundant call. I think it should be off entries. Yeah, okay, map.off entries, or you just create a class that represents this. That is completely up to you, of course. Since we really just need this here once in this simple project, I decided to make this a map. However, things go wrong. So in the IO exception case, we want to return a response entity dot status. Yeah, with internal server error, because this is likely a server issue here that something on the file system couldn't be created. In the case of illegal argument exception, it's rather bad request. So that's an issue of the client that they attached an image with the wrong MIME type or so. But that's the upload function. Next up, the download function. So we're gonna have a public response entity, which this time returns a resource. So here, resource from Spring Framework, download image, which retrieves a path variable image ID. So this is from the get mapping that we pass here, which needs to come from slash. Let's directly pass in the image ID here. So we access this by slash images slash image ID. And this image ID will be put here as a parameter, and we can work with it. Let's also have a try and catch block over here. Here, only IO exceptions can happen. So we have IO exception E, in which case we would say response entity dot status internal server error dot build. And for the try block, we again retrieve our metadata object now. So here we are now looking for a particular image in our DB with the ID image ID. So we can say that's equal to image service get image metadata by passing in our image ID. We then get this as a resource. So we have our resource, which we get from image service dot get image resource. Pass in the pass in the image ID, and then we can return response entity dot OK, pass in our resource. And here it's also important to send some additional information as headers. So one header, no, never mind. This resource, this needs to be passed as a body. So body as a resource. But then we can say in between, we have one header that is attached to the response, which is the HTTP headers.content disposition. This is just very typical for such downloaded files, which contains information about this file. So here you can see the AI already suggests here. It's actually exactly the same. So resource get file name, which, no, this should actually be the original file name. So metadata original name. But other than that, we say, hey, that's an attachment. The file name key or property here must be called like that. We have quotes and then the file name in quotes. That is just the format that we typically want to attach to these kinds of responses. We're going to pass a content type of the image that was returned here, so the client can also work with that. Media type dot parse media type, and we simply parse the MIME type from our metadata object. And lastly, as the content length, to also tell the client more about that, that's metadata.size. Last but not least, something you typically want to also add if you store these images here directly, or maybe also if not, that you set maximum file upload size limits. That's something we can set in our application properties file by saying Spring Servlet multipart request max request size. That is set to 10 megabytes by default. So we need to distinguish between request size, which is the entire bytes amount of the request, and the max file size. So the maximum size of a single file attached in a multipart request, where we could possibly also have multiple files. So I want to set this one here to maybe 5 megabytes to consider most images, but not allow clients to really upload gigabytes of content here. And then, if we want to test this, you of course have to now spin up a local MongoDB instance or connect some kind of Mongo Atlas cloud database here. I will simply spin up a simple MongoDB test instance here locally. So I will just go to my root folder here, create a new directory and say MongoDB temp or so. So MongoDB can install its temporary files in this directory, and then we can delete it afterwards again. We can spin this up with MongoDB. So you of course have to have this command line tool or MongoDB as a service here installed on your environment. But then you can say MongoDB --db path, and you reference the MongoDB temp directory. And if you hit enter here, then you will see something like this. It says shutting down, which I'm not sure why. Let's try this again. Yeah, now it's actually keeping the connection active here. If we take a look in the directory, there are some kind of MongoDB files. We don't need to care about that. But now the test DB is active. That's also the default DB that Spring Boot will connect to. And if we launch our backend, then you can see we see logs. We don't see any crash. We don't see any connection issues, which is exactly what we want. So we can now go to Postman and test this. By default, Spring Boot is running on port 8080. So make sure to put your HTTP localhost 8080 URL here. I chose a slightly different name here, but we first of all, of course, have to test the upload functionality. My other backend is stopped, so we're definitely talking to the new one that we've built here. The URL looks correct to me. The file is still attached. So in Postman, if you want to attach this, go to body, form data, then select file here. Or you can attach a text part or a file part, and then simply upload your file. If we click send, then we get an OK response. We get the original name, we get the image ID. And if we copy this image ID over to our other endpoint, we didn't call it download, but I like this format actually more. So we have a GET request, HTTP localhost, our port, /images, /our ID that we've just copied over. And if we now click send, yes, our beautiful image here is still showing, which means everything is working as expected. And if we take a look in our backend, in our console, then we should also see, not sure if there are any logs. No, seems like it didn't log anything in regards to that. But what we can test is, in our images folder, which now appears, we have our date-like hierarchy here, and our first image is in there. And if we open this, then you can see my beautiful face that was successfully uploaded here. Again, that's not the place where you want to store these images on a production setup. You can, of course, also make this maybe some kind of properties field here, what the relative image path is depending on your Spring Boot profile. I have a separate video about Spring Boot profiles. But other than that, this is how you store images where your Spring Boot backend is running on. If you now, of course, want to upload these images to some kind of cloud provider, as I said, for example, AWS S3, then this still works very similarly. So you would, of course, retrieve your image server-side here as a multipart request. You get the input stream of that, and then very often you have some kind of function from that SDK from S3, for example, that also receives an input stream and then performs the upload for you. But either way, I think it's quite helpful if you've implemented both of these approaches once, so you understand the differences, understand in which case it makes more sense to stick to local images, in which case it may make more sense to stick to a cloud provider. But of course, if you store these locally, then you also have to take care of things like backups. In the end, you just have kind of a single point of failure in your server if you do this. Because if your server breaks for some reason, then it's not just your backend that is gone, but also all the entire images that have been stored there. But again, it's really a trade-off that you have to consider here for your particular backend you're building. If you're just building some kind of hobby project or smaller project, then storing these images locally can also save you some bucks. Thanks so much for watching this video. If you want to learn more about Spring Boot, then check my channel and don't forget to leave a subscribe because I regularly upload more Spring Boot videos, both in Java and in Kotlin. So if you want to take a look at a language that I personally consider much better than Java, also for Spring Boot, then take a look at that. Get a feeling for how Kotlin is like for Spring Boot and maybe also some Android or Kotlin multi-platform development, which my channel is full of. Thanks so much. See you back in the next video. Have an amazing rest of your week. Bye-bye.